So now let us discuss about the refraction through a concave surface. So let us take an object O here, and the rays from this object O is incident over this concave surface. Now let us draw a normal from the point C, where C is called the center of curvature of this concave surface. Now this incident ray will be refracted in this way. So now the angle of refraction is ray backward, then it will form an image here. So this angle is also equals to this angle, opposite angle, so this angle is also equals to R. Now consider the height of this point from the plane H. Now let us mark some of the points, like this is A, this as B, this is pole P. Now consider this angle as alpha, this as beta, and this as gamma. So this is basically the diagram of the refraction from a concave mirror or concave surface. So now as we know that the distance from the object to the surface is u, the distance from the image to the surface is v, and the distance from the center of curvature, or we can say as radius, of this surface is r. So now in triangle OA, and mark this point as M, OAM, in triangle OAM, the sum of alpha plus I will be equals to gamma as the exterior angle property. So alpha plus I is equals to gamma. From here we know that I is equals to gamma minus alpha. Now in triangle I, A and M, beta plus R will be equals to gamma, and beta plus R will be equals to gamma. So from here R is equals to gamma. I forgot to tell you one thing, that the refractive index of this angle is mu 2, and the refractive index of this angle is mu 2, and the refractive index of this uh, here is mu 1. Means the refractive index of the concave surface is mu 2 and the refractive index of the outer one is mu 1, such that mu 2 is greater than mu 1, means it is a dense, and it is means a rays. So sin A or sin R will be equals to 1 mu 2, as we know that the ray is going from the mu 1 to mu 2, so it will be 1 mu 2. So sin I will be equals to I, because the angles are very small, these alpha, beta and gamma are very small, so sin I will be equals to I, and sin R will be similar in equals to R. So now we can write here as is equals to mu 2 over mu 1. So mu 1 I is equals to mu 2 R. So now we have to put the value of I and R from these two equations. So mu 1 into gamma minus alpha is equals to mu 2 into gamma minus beta. So now multiply this, mu 2 gamma minus mu 2 beta. It's mu, not u, it is mu. Now take both the gamma in one side and alpha and beta in other side. Now here gamma is common, so it will become mu 1 minus mu 2 is equals to mu 1 alpha minus mu 2 beta. Now we just have to put the value of these angles, like gamma, alpha and beta, and as we have already considered that the angles are very small, these alpha, beta and gamma are very small, so tan of these angles means tan of gamma will be similar equals to gamma, tan of beta will be similar equals to beta, and tan of alpha will be similar equals to alpha. So what is tan gamma? Let us find it from the diagram. So tan gamma is, we know that the tan theta is equals to perpendicular over base. So perpendicular is h and base is r, so it will be taken as minus h upon minus r into mu1 minus mu2 is equals to mu1 into h over u minus, this is u, this is refractive index mu1, and minus mu2 into this mu2 into beta, that is h over v, and minus minus will make this as plus. So now on solving this, mm, h is common from this side and h is also common from this side, so h will be cut down from both these h, so both this h will be cancel out. So mu1 minus mu2 over r, multiplying this minus sign into this equation, so it will become mu2 minus mu1 over r is equals to mu2 upon v minus mu1 upon u. This is the formula for the reflection through a spherical concave.